Welcome back, Math 1. This lesson's on 9.c, which is solving systems of linear equations using substitution. Two of the most common methods of solving systems is substitution and elimination. And we're going to start here with substitution. Now the goal, and this is the very important part, the goal when using substitution is to break the system of two equations and two variables down to one equation and one variable. We are not able to solve equations that have two variables in them, right? So our goal is to take this, two equations and two variables and break it down to one equation so that I can solve for one variable. So the steps to solving. The first thing you're going to do is isolate one of the variables in one of the equations. Right here, you want to work smarter, not harder. So you want to solve one of the equations for one of the variables. Then what you're going to do is substitute the value of the isolated variable into the other equation. This is where our goal is accomplished, right? And that will allow for us to solve for one of the variables. Then we're going to go ahead and substitute the value of the variable from that step 2 back into one of the equations and solve for the other variable. Then you will gather your ordered pair solution x, y. So let's take and look at an example here. Now when I use substitution, I like to use what I call a T-chart. And I like to put one equation on one side and the other equation on the other side. Now, when I use substitution, right, I look, this equation, no variables are isolated. This equation, I have x isolated. So what I'm going to do is take this value of x and plug it into 4x plus 7y equals negative 2. So we're going to get 4. Now, I'm going to kick the x out and replace it with its value on the other side, negative 2y. So 4 times negative 2y plus 7y equals negative 2. Now notice, this is now broken down to one equation, and the one variable I can solve for is y. This gives me negative 8y plus 7y equals negative 2. So negative 1y equals negative 2. When I divide by negative 1, y is equal to 2. Now, if y is equal to 2, now I got to find x. So all I do is take this value of y, come over here, and substitute 2 in for y. Negative 2 times 2 will give you negative 4. Ordered pair solution here, negative 4, 2. Now, example 2, right? If I go ahead and I make my T-chart, and I'm going to put the equations on each side. And then from here, I look, do I have one of the variables isolated? Well, if I look at y equals negative 4x plus 5, the y coordinate is isolated here. So therefore, I'm going to take the value of y there, and I'm going to substitute it in over here. So 8x minus 2. I'm going to kick the y out and replace it with its value, negative 4x plus 5. Right? And then I'm going to go ahead and solve this equation for x. So 8x. And this is going to give you plus 8x, right? Then minus 10 equals negative 42. First, I combine like terms here. 16x minus 10 equals negative 42. I'm going to go ahead, add 10 to both sides. 16x equals negative 32. Divide by 16, x is equal to negative 2. Once I have the value of x, now I can come over here and plug that value in to find y. Y equals negative 4 I'm going to kick the x out, replace it with the value I got over here. So negative 2 plus 5. So y is equal to 8 plus 5, which would be 13. Ordered pair solution, negative 2, 13. All right, for the next example, right? Notice here that when I look at my two equations, I put them in the t-chart. When I look at the equations, I notice that I don't have x equals, nor do I have y equals. So none of the variables are isolated. So what I have to do is pick the easiest variable out of the two equations to isolate. So I'm going to choose the easiest one to get by itself to be the x term in this equation. So if I take x minus 6y equals 5, to solve for x, I need to get rid of negative 6y. So I'm going to add 6y to both sides. That would give me x equals 6y plus 5. Now I could take this value of x and plug it in the equation on the left here. So we're going to do 2 times 6y plus 5, bring down the plus 7y, equals 48. To solve this, distribute 12y plus 10 plus 7y equals 48. 12y plus 7y gives me 19y plus 10 equals 48. Subtract 10, 19y equals 38. Divide by 19, and y equals 2. Once I have the value of y, now I come over to the other equation, and I plug it in. X equals 6 times 2 plus 5. 12 plus 5 will give me 17. So the ordered pair solution for this system would be 2, 17. Now, the last example. Okay, I make my t-chart. And when I make my t-chart, I get y equals negative 8x plus 16, y equals negative 3x plus 46. If I notice, each equation is solved for y. So this one, it doesn't matter which value of y we plug in. So I'm going to take this value of y, and I'm going to put it in the place or plug it in the place of this y value. So I'm going to say negative 8x plus 16 is equal to negative 3x plus 46. So all I did was take this value of y and plugged it in here. So now I can go ahead and solve for x. So bring my variables to the left by adding 3x, constants to the right by subtracting 16. That gives me negative 5x equals 46 minus 16 is 30. Divide by negative 5, and x is equal to negative 6. Once I have x, now I come over here, plug that value of x in. Y equals negative 8 times negative 6 plus 16. 48 plus 16 would give me 64. So the ordered pair solution here would be negative 6, 64. This should give you a good idea on how to solve systems using substitution. Go ahead, work on the student practice, and let us know if you have any questions.